Now we're moving on with our rates videos, and this one is about what affects the rate of reaction. And we have 4 things here: temperature, concentration, pressure, and surface area. Now, Ms. McLaren, we know from previous experiments that if you increase the temperature, the rate
increases.
The rate increases, absolutely right. Now, we have to be able to explain that in terms of the collision theory. So let's start us off. Why does the rate increase if you increase the temperature?
Well, if you increase the temperature, that means the particles will have more energy.
Excellent. What sort of energy do they have? More
kinetic
energy. Very
and
good.
In order for a successful collision, you need to have particles with a sufficient energy of activation.
Ah, yes.
So that means there'll be more particles which will have that energy of activation and above. So when they collide more frequently, then that means there's going to be more successful collisions per unit time. Is that correct, Dr.
That
Gordon?
is correct.
Thank God.
So you've got particles, more particles with at or above the activation energy, and therefore you'll get more successful collisions. And because they're moving faster, they are going to collide more frequently, so you'll get more successful collisions per unit time. So there are 2 factors, but the most important one is the one to do with activation energy.
So as the particles, more particles have a higher energy.
Excellent, yes, good. Now, let's move on. Concentration. Concentration and pressure go together. How would you explain the increase in rate of reaction when the concentration increases?
Well, the rate would increase, and the reason being, if you've increased the concentration, then it means you have more particles, which means you have...
Per unit volume.
Per unit
volume, more particles.
That's right.
Right.
So in a sort of fixed volume, you
Yes.
get more particles, which means they're going to collide more often.
Yes.
Which means, by that logic, you're going to have more successful collisions per unit time. Is that
More
correct?
successful collisions per unit time. Excellent. So for concentration, you just say there are more particles in a given volume.
That's correct.
Therefore, there are more collisions. Therefore, there are more successful collisions per unit time.
I think that's right, Dr. Bourne.
Great. Now, what about pressure?
Pressure will only refer to gases, and it's very similar to the concentration one, because if you increase the pressure of a gas, you have more particles in a fixed volume,
Yes.
which means again you have more collisions and you have more successful collisions per unit time.
This is getting wonderful. Now, just clarify with the pressure. If we have a fixed volume, we'd have to increase the pressure from outside, because sometimes we make the volume smaller in order to increase the pressure, don't we?
That's correct.
So we
So
get
what
more
we
particles
do-
per given volume.
Yes, so we could
Okay.
decrease volume, which means that you increase the pressure.
Increase the
so
pressure.
that would actually
Work.
be the same.
As the yes, increasing, absolutely. Okay, and finally, the last one, not to be forgotten, surface area.
Well, surface area will only affect a reactant which is solid. So if you increase the surface area, it means that it's going to be more powdered. So therefore that means one of the reactants will actually be more exposed, or there'll be more particles available
Yes.
to collide with the other reactant.
Perfect. So if you increase the surface area, there are more available particles to collide with the other reactant, so you get more collisions per unit time, and therefore you'll get more successful collisions per unit time.
So the mass will be the same. So if you've got a sort of, let's say, lump of calcium carbonate or powdered calcium carbonate, but with the powdered one there's more particles of calcium carbonate available
Exposed, right.
to react with, for example, the acid.
Excellent. Well, I think we've sewn that up, Miss McLaren.
Yes, hashtag, let's keep it
Keep it
fresh.